So thanks very much for the welcome, Joe. Thanks everyone for coming along. Yeah, so I'm going to talk about space. There's lots of stuff to cover. I've got far too many slides. I'll go through them at a rapid pace. I've avoided too many plots and graphs and things. If anyone's got any burning questions during the talk, then please fire away, just shout out, and I'll try and address them, and then we can have a longer chat at the end. So I'm sure everyone here appreciates how much space technology actually influences our daily lives. Sat-navs, when's the next bus arriving, weather forecasts. We're now so used to seeing where all the clouds are. We don't realize that they're coming from, or lots of people don't realize they're coming from a satellite sharing an orbit with the TV satellites 36,000 kilometers away. And of course, satellite TV as well, a huge industry. So this is all stuff that's happening close to Earth. It's a huge industry. I'll flash by this really busy graph of all the different sectors that have been identified in the UK, but there are loads of ones including broadcasting, telecoms, navigation, GPS of course. And then this is how the work in the UK is split according to sector. So broadcasting is the biggest, so satellite TV, etc., telecoms, and GPS and things. And then on the left, we've got how the space sector is split up by what type of work is actually done to contribute to it. So about a third of it is actually building satellites. This is by turnover. Space transportation, so rockets, fuel, etc. Ground segments, so the dishes you have on the ground to collect the data and distribute the data. Research and consultancy, building spacecraft themselves, and then I think what I do is actually quite a small proportion of this, so just a couple of percent, and that's using data from spacecraft to learn about the universe around us and also to learn about the Earth as well, monitoring the Earth from space. So in terms of jobs, it's a bit of a fuzzy boundary, but we think there are about 34,000 direct employees in the space sector in the UK, and about 72,000 jobs which are indirect and rely on it. So it's a steadily growing sector as well, and I mean everyone here is used to using your phones to navigate, and most of our phones use the GPS system, which is American, so run by the American military, so fairly high precision, but at any point the US could lower the resolution of GPS, and then we don't know quite as well where everything is. There's also a Russian system, GLONASS, which some phones and things also use, but the European Union and ESA, the European Space Agency, decided to build their own system, so we're not reliant on other countries' systems as well. So this system is being put together now, so it's called Galileo. This is just one of the constellation of dozens of spacecraft that will be launched. So the first were launched a couple of months ago. They were unfortunately put into the wrong orbit, but the constellation has been started. So it's like a production line. I've seen the production line in Bremen in northern Germany. So a company there, OHB, are building the satellites. And then Surrey Satellites from Guildford, they're building a large part of the components that go inside. So they're working together, making these satellites, and then over the next few years they'll be launched, and in a few years' time our phones will be using Galileo, much more precise measurements, so we'll know to within a few centimeters where our phones are, and we won't be reliant on other countries. So that's just one example of where space industry's growing as we speak. So the UK does have a space agency. Here's its name, which is quite self-explanatory. It's only been in existence for a few years, so it's brought together bits from different organisations. So the UK Space Agency, they're part of Department of Business Innovations and Skills, and they fund a lot of the work that's done in universities and in other sectors as well to build satellites and explore the universe around us. And so they build the satellites and operate them with other bodies as well outside the UK. And then we've got funding from a research council called the Science and Technology Facilities Council. So they actually pay for scientists to do the work. So I know this is a bit tedious, just to give you a bit of background how our space industry is funded. So we're members of the European Space Agency, so all the member states here are shown in dark grey, and there are a few associated states, including Canada. So every country pays a subscription. So for the UK, it's just under £300 million at the moment per year. So that goes to ESA, and then the UK industry gets contracts back in return, which are about the same amount in return. So a lot of that money we pay to ESA, we get back. So let's, now we've got sort of the background of where all the money comes from and things, what do we do in space? So unmanned spaceflight, that's the area I primarily work in. So the European Space Agency, same with NASA and other agencies in Russia, Japan, etc. We launch missions to explore the universe. So some missions are launched above the atmosphere to look at stars and galaxies and things which we can't see from the Earth, so at wavelengths like infrared and ultraviolet. And then lots of other missions as shown here that go to other planets. So moving out from the Sun, we've got Solar Orbiter, which is being built at the moment in Stevenage to observe the Sun, really close in. It'll go inside the orbit of Mercury. There's a mission called Bepi Colombo to go to Mercury. Got missions at Venus, Mars. We've started building a spacecraft called JUICE, which is a terrible name, but it's Jupiter Icy Moons Explorer. So we've just started buying the components and things for that now, and it'll launch in 2022. It'll get to Jupiter in 2030. And in 2032, it'll go into orbit around one of the moons of Jupiter. So it's a really exciting, big mission that's just started. We've got Cassini-Huygens at Saturn, which I'll come back to in a bit, and Rosetta, which I'm sure many of you have heard about in the past few weeks. So the European Space Agency, it's growing in confidence in what it can do. So the first few years, it was staying close to Earth, observing the Earth and things, and just staying in Earth orbit. And this spacecraft was actually the first to leave Earth to explore somewhere else in our solar system, and this was Giotto. So in the 1980s, Comet Halley was coming along. There had been a big plan for NASA and to launch a big spacecraft to Comet Halley and then drop this European probe as it went past to fly past Halley close up. But NASA pulled out, but Europe went ahead with their own spacecraft. So this was it's a communication satellite, but they changed bits and made it suitable to send out into space. So you can see it's not huge. There's a technician there, so someone standing about that tall. And it would go through Comet Halley at about 68 kilometers per second. It's incredibly fast, so it's got a bumper shield so dust doesn't destroy it, and a camera. And it was launched from French Guiana in 1985 on an Ariane rocket. And then in March 1986, if I can find the play, we got closer and closer. Let's skip to the end. We got closer and closer to Comet Halley, and got images of the nucleus of Comet Halley. So comets had always been seen as fuzzy objects in the sky moving with respect to the background stars. And Giotto got really close and showed us what's at the heart of a comet. So this is the nucleus of Comet Halley. It's a few kilometers across. So it's a really dark ball of ice and dust. And when it gets close to the sun, all that stuff melts away and you get jets of gas being thrown off into space. And then Giotto, after that, went on to another comet in 1992. By then, the camera had been destroyed, so all the other instruments almost were working those. So that was a great success despite that. And other comets have been explored in the meantime as well. So this one shows that comet nuclei, this is from a NASA mission, are surrounded by snowballs. So these are measurements that you can only make by going there. Although you might argue that you can learn a lot from space, looking at objects through telescopes on Earth. It's only by actually going to comets like this that we can really understand what they're made of measure the composition, all the exactly what the dust and gas is made of, and these are thought to be the leftovers of when the solar system formed, and that's why the decision was made to launch a really ambitious mission, and that's Rosetta. So Rosetta's really big, and that's because it needed to travel really far away from the sun. So it uses solar panels to get power, and it measures 32 meters from tip to tip. So it's a huge, long spacecraft. So a person standing next to this would only reach up to about halfway up this big box. So it's got a range of instruments on board to study the comet, with cameras, with the lights that we're used to seeing with our own eyes, also infrared, ultraviolet, and it can also taste the gas that's around the spacecraft. It can collect dust. It can sample the dust and measure exactly what each individual dust grain is made of. And it's carrying a lander called Philae, which I'll come back to in a moment. So Rosetta, although most people only first heard about it earlier this year, it's been in space for a very long time. So it was actually launched in March 2004. And it took ages to arrive at the comet. So the blue line here is the comet's orbit. So you can see it gets quite close to the sun, almost the Earth's orbit when it's at its closest, and then the orbit of Jupiter when it's at its furthest from the sun. And for Rosetta, what they wanted to do was to travel alongside the comet. So all the other spacecraft that visited comets just went past at high speed. So you only had a snapshot, you just had a couple of hours to take all the measurements you could, and then that was it. The mission was basically over. So the big difference with Rosetta is it's gone to a comet and it's staying with it. So over the past 10 years, it's flown past Earth a couple of times, Mars, and a couple of asteroids, and then it was so far from the sun, even its huge solar panels couldn't provide it with enough power. So in June 2011, it was switched off. And then all this time, until January of this year, it was is in hibernation with just one countdown timer ticking away to wake it up in January of this year. And thankfully, that happened. And then by August, they'd moved closer, much closer to the comet, and actually arrived at the nucleus. So the nucleus is the heart of the comet. So it was a bit of a surprise when they started to get pictures of the comet back. Looking at it through the Hubble Space Telescope, they'd estimated it was sort of roughly spherical with a few knobbly bits on it. But it's actually duck-shaped, which was a huge surprise. And for those wanting to land on it, they realized they had a bit of a challenge. So you can see, even though it's still really far away from the sun, it started giving off gas and dust from this neck region between the two bits, the head and the main body. So the sun started melting the ices and giving off these gases. And that's the view from the Earth. So it shows you the value of actually going there and looking at these objects close up. So this is one of the largest telescopes on Earth, an 8-meter wide telescope in Chile. And just to give you a sense of scale, this is where we are now. It's a bit darker at the moment, though. And if we plonked the nucleus of the Rosetta target comet down onto London, that's how big it would be. So those of you who live in Bloomsbury or Paddington, sorry for squashing you. So the images that it's sent back are really amazing. So this is a view from the lander, but before it was released. So the lander is still attached to the spacecraft. It's looking down the solar panels, and you've got the comet nucleus in the background there. And it's a really bizarre place. So it's tiny, and because of that, its gravity is really, really low. So if you were to try and walk around, just the gentlest of steps would send you flying off into space, and it would take you tens of minutes to come back down again. So this is the valley between the main body and the head of the comet as well. So down if you're over here, is that way, but if you're on the other side of the valley, it's that way. So you could have astronauts on either side of this valley looking up at each other and just seeing each other's heads. And this is the lander, Philae. And just to give you a sense of scale, it's me looking very self-conscious there, in the same shirt, actually. Oh, okay. And then it was released on November the 12th, just a few weeks ago, to land on the comet. And as Philae drifted away, it took pictures of Rosetta as well. It's not the best photo in the world, but here's the Rosetta craft and the solar panels and the sun's shining into the camera. And Philae took 7 hours to fall 20 kilometers. So that's how weak the gravity was. And the cameras, these are all taken from the Osiris cameras, the science cameras on the Rosetta spacecraft. They actually captured Philae drifting across the surface of the comet. It touched down just here, and they can see a little dent where it hit the surface, and then it bounced back up again. When it first landed, it was supposed to fire harpoons and fire a small thruster to push itself down onto the surface, but unfortunately they didn't work. So it went back up into space for about an hour or so, and then came back down again. And then there was one of its legs clipped a cliff top. It did another proper bounce, and then finally it landed on the surface. So this is one of the pictures it took before the first touchdown. So they chose it because it was smooth, really easy to land on, and it looks perfect. But unfortunately, it didn't stay there. This is the final resting place. So you can see one of the feet here, and it's actually facing a cliff. So because it was quite dark, it didn't get enough solar panel power to keep going for ages, but it had batteries. So it had a set of commands, measurements to take just running off batteries, and it managed to do that for the 3 days it was on the surface before it went quiet. So all the scientists and all the instruments got data back. So it has been a huge success, especially when you consider that they only thought that it was a 60-40 chance of it actually landing successfully. And the solar panels will always try and recharge the batteries. So with there's a big hope that in a few weeks or a couple of months' time, when the sun's higher in the sky, Philae will come back to life. And this is just one of the images it took of this bizarre surface with, you can see the Milky Way and background stars there as well. So it's been an amazing success, and Rosetta isn't over. The big point is that we're staying with the comet now, and we're still drifting closer to the sun. We'll get to the closest point to the sun in August of next year. By then, we're expecting the comet to be really active, throwing off lots of gas and dust. We might see bits of the surface being eaten away. It's all ice, so it's all going to melt away. We might see changes on the surface, and hopefully Philae will come back to life as well. So Rosetta should carry on working till the end of next year. So all the instruments that are on the main spacecraft will carry on working. So it's been a huge success for the European Space Agency. And one of the first times when I was in the US when it happened, where the media in the US were actually covering a European space mission and the amazing successes that it was having. So it was a really nice change to have things happening that way around. So very briefly, just to show you how what we do in the UK fits into all this, how does a group like ours at UCL contribute to space exploration? Well, this is where I work. Joe mentioned it earlier. We're in a village called Humbury St Mary in Surrey. So we are part of UCL, but definitely very off-campus. And NASA and the European Space Agency and also the Italian Space Agency, they wanted to build a mission to Saturn called Cassini. So the proposal went in the 1980s. They collectively decided to go ahead with Cassini. And so they decide on the mission, what they want to do, and then there's a call for groups all around the world to propose instruments for the mission. And they'd identified what types of instruments they wanted. So this is a huge spacecraft, weighed about 6 tons when it was launched. So it's got engines to slow down. This one, it's powered by plutonium because it's going so far from the sun. So sunlight's very weak there, and you can't use solar panels easily. So groups around the world, universities and other research institutes proposed instruments to fly on Cassini, and we at UCL proposed an instrument with a group in Texas and other colleagues to measure the gases around Saturn and its moons. And it's called the Cassini plasma spectrometer. So our bit measures electrons. So it's almost a vacuum around the planets, but it isn't quite a vacuum. And we're measuring the few particles that are around. So Cassini, a very ambitious mission as well. You can see a person standing down there to give you the scale of the thing. It's enormous. And again, it took a very long time to reach its target. So it was launched in 1997. So when the instrument was being put together, I was still a student, and I had a job as a clean room cleaner, which was very frustrating because it looked clean to begin with and exactly the same afterwards. But my contribution was to clean the clean room when the instrument was being built. And then years later, I was working on the data being sent back from Cassini. So launch in October 97, arrived in June 2004, so it's been there just over 10 years. And this big round thing here was a contribution for the European Space Agency, which is a lander to go to the moon Titan. So it's the biggest moon of Saturn, second largest in the solar system. So here's the Huygens probe, the contribution from Europe. So a big heat shield. And then in the background you can see the main Cassini spacecraft as well. And this is being put together at the Jet Propulsion Laboratory in Pasadena, California. So Cassini was launched in 97, and then we had a long wait, twiddling our thumbs while it made its way out again. It flew past planets close to the sun first. And the reason for doing this is that if you go past a planet, you can sort of cheat and slow down the planet a tiny amount, and the spacecraft basically robs some of the speed, and the spacecraft speeds up. So by flying past the Earth and Venus, Cassini built up enough speed to go out, to go past Jupiter in 2000, and to reach Saturn in 2004. So the observations have been, that's how complex the orbit is around Saturn. It's an amazing feat of navigation to go around Saturn and visit all its moons. So before arriving, we had a sneak preview of what was to come. So this is the moon Phoebe. It's probably a captured comet as well. And then we had a very tense few hours on July the 1st, 2004, where Cassini had to fire its engines to get into orbit around around Saturn, and thankfully that worked really well. So we've been getting amazing data back from Cassini. It's still working brilliantly. So this is quite a recent image of Saturn's North Pole. You can see the rings in the background here. And you can see there's a hexagon around the North Pole in the clouds. And this is a wave, like a jet stream in Saturn's atmosphere. But it's moving north and south, exactly the right period to form a beautiful hexagon. And if we zoom in to right at the middle there, the North Pole, we've got this huge storm the size of the Earth, a big vortex at the North Pole of Saturn. So it's a really amazing place. These are the shadows of the rings on Saturn itself and one of the moons at the bottom there. And we've also been able to get movies of the rings. So the rings look perfect from the Earth, but if you look at them close up, you saw some of the moons going past. If you look at this outer ring here, it's not smooth. There are lumpy bits. This is stuff that there's no way you can study from the Earth. And it's only by having a spacecraft like that there staring at the rings for a long time that you can learn a lot about the rings and what goes on there. And Cassini's been there for long enough to see the different seasons on Saturn. And this is when the sun was crossing the equator, so that's called equinox, and the sun was exactly side on to the rings, and when that happened, you can see that the rings aren't perfectly flat. There are bumpy bits, casting shadows on other bits of the rings as well. And as well as Saturn itself and the rings, we've also got the moons. So most of these, what you're looking at is water ice, and water takes the place of rock when you're really far away from the sun. It's so cold that water behaves like rock does on the Earth. So we have ice volcanoes, active ones as well. So one of the most bizarre places is Enceladus. So this is how big it would be if you plonk it in the North Sea. It'd lower the temperature even more. And we discovered with Cassini that the South Pole has actually got a geyser. There are lots of jets of ice and dust coming, being thrown out of the surface of Enceladus. So it's effectively a volcano, but it's an ice volcano rather than a rock one. So under the surface, there's probably a layer of liquid water behaving like lava does here on Earth. And here's a close-up of one of the fractures where all this stuff comes out into space. And just to show you how complex these flybys by Cassini are, this is a flyby of Enceladus in 2008. So we've got lots of instruments on Cassini, and they all want to look in different directions. So we have long conferences by phone to discuss which instrument's going to look where, for how long, etc. So this shows the views from the cameras. This is from an instrument for looking at microwaves. And as you can see, time's obviously sped up a lot. But all the instruments get their turn looking at Enceladus. And for this flyby, our instrument was one of many that had priority when we were closest to Enceladus. So we swept past at about 18 kilometers a second. So all the dust particles came into our instrument, and we were able to measure the ice and the gas that's coming out of the moon. So all of these instruments are run by teams at different universities, most of them in the US, but also here in Europe. And so we all had to work together. The US people having to get up early in the morning to talk to us, and us working into the evening to discuss how these observations are made. And Enceladus has been an amazing place to study. So here's a real image from Cassini showing the jets coming out of the surface. And there was an artist working for National Geographic in 1981 who, although there were hints that there might be volcanoes there, this artist, he or she, went ahead and drew volcanoes on Enceladus, which was quite a good prediction of what would be seen a bit later. So Enceladus was actually discovered from Slough. William Herschel, after finding the moon Uranus, was made the king's astronomer and was given a residence close to Windsor so the king could visit him. So this was the telescope he used to visit to discover Enceladus. And then in 2009, we had the Cassini team. We hosted a meeting at UCL, and we took them to Greenwich. So here's the prime meridian here, and the remains of the telescope are still there. But you might notice it's a bit shorter than it was when Herschel used it, and that's because a tree fell on it. But it was nice to get the world's experts on Enceladus reunited. Well, not reunited, but back at with the telescope, which was used to first find this bizarre place. So, with Cassini, we've studied lots of the other moons. This is Dione. You can see these huge cliffs of ice here, splitting these craters into two. And Titan, which I mentioned earlier, the biggest moon of Saturn, which is really interesting because it's got a really thick atmosphere, and it's actually thicker than ours. So if you're standing on the surface, it's like being at the bottom of a swimming pool here on the Earth. So the pressure is just a bit higher than we're experiencing now. It's got haze layers, so you can't see down to the surface. But the European Space Agency probe, went down to the surface in January 2005. So here's a movie of what Huygens saw. So based on the data that it gathered, and actually landed in a dry lake bed. But this lake isn't a lake of water; it's a lake of methane and ethane. So it's such a cold place. The rock is water ice, and the liquids are methane and ethane. So it rains methane and ethane. So like we have a water cycle on Titan, it's a methane and ethane cycle. So a really bizarre place. So this probe was designed without anyone ever having visited Titan before. So it entered the atmosphere, parachutes opened, and it came down to land on the surface of this bizarre world. And down on the surface we found pebbles, almost certainly water ice pebbles that used to be on on this lake bed. And we also saw the parachute drifting over as well after Huygens came to a halt. So we've got footsteps, human footsteps on the moon, and that's the only body where we've got human footsteps, and maybe in a few decades, or more realistically, probably a century or two, we might have footsteps on Titan as well. So other evidence that Titan's similar to Earth, you can see riverbeds, streams, and also dunes as well. These black lines are dunes of probably something similar to sand, but made out of water ice or lots of carbon-based molecules and things. So it's a really bizarre place. So now I'll move on to human spaceflight. So this is a real whiz through all kinds of areas, but there's so much going on at the moment. It's a really fascinating area as well. So we've come a long way from Gagarin's first flight. So this is the capsule that carried him back to Earth, but he didn't actually land in that. He parachuted out before it hit the ground. And of course, the stupendous success just a few years later when astronauts from the US landed on the moon successfully and came back safely. In the 1980s, 90s, and into to 2011, we had the space shuttle program, and that was used with Russia as well to build the International Space Station, which I'll come back to in a minute. This is going through the history of spaceflight really quickly, but in the early 90s, the first British astronaut flew to the Mir space station, Helen Sharman, and after the Cold War ended, we had Russia and the US working together, first with the space shuttle visiting the Mir space station, and then later, as I just mentioned, building the International Space Station together with Europe, Japan, and Canada as well. So a country that isn't involved in the International Space Station is China, and they've been catching up really quickly as well. So they have their own small space station, and the latest mission there, Zhenzhou 9, docked. They had 3 taikonauts, as they're called in China, visited the space station, and they're, I'm sure in a couple of decades, they'll be carrying out missions equivalent to what Russia and the US are carrying out now. So the International Space Station, which you can see very easily with the naked eye, it's quite easy to find out when it's passing over. It's an enormous structure, housing several astronauts at a time, so carrying out experiments. And most of these components have been carried out by the space shuttle and also with Russian rockets as well, and they've all been bolted together in space. And now it's getting into the swing of things, and there's proper research being carried out there. But it's true, it's really expensive to do this. Flying people into space is a lot more expensive than sending unmanned spacecraft. But clearly, there's the desire to do it by many people, and it is an enthralling thing. The fact that we have the ability to go into space and to push further back to the moon and beyond, which should happen in the next few decades. So for missions further into space, we need the experience of spending a long time in space, so spending months in space on the International Space Station. So we found that astronauts, they're affected by lots of there are lots of side effects of flying in space, so you have to exercise regularly to avoid bone deterioration, etc. So this isn't just to do pure science as well. It's going to be used for long missions deeper into space in the future. So the astronauts that are up there at the moment are a mix of nationalities from Russia, the US, and Italy, representing the European Space Agency. As this is Expedition 42 to the International Space Station, so the significance of that number wasn't lost on them. So this was their team, the unofficial team portrait. Don't panic, yes. And next year, although there have been several NASA astronauts who were born in the UK but have taken the US nationality, Tim Peake will be the next British astronaut flying for the European Space Agency late next year, probably for about 6 months. So his mission will be called Principia, so he'll be sent up to the space station late next year, so I'm sure we'll hear a lot about that. And Blue Peter organised the naming of the mission. So at the moment, the space station, the only way to get there for the astronauts is with the Soyuz spacecraft. So other countries pay Russia a lot of money for seats on the Soyuz spacecraft. But the space station's also refueled and replenished with food and fuel and water, etc., by several craft. So there's a Progress spacecraft from Russia, very similar to Soyuz. European Space Agency's provided a spacecraft called the ATV. So that is huge, and I'll come back to the back half of this in a moment. I'll explain that. So, but it's really big and carry huge amounts of cargo up there. Also, the US is paying for private companies to send supplies up there as well. So this spacecraft's called Cygnus, and Japan as well are sending up resupply missions as well. This is their spacecraft. So I'm going to dwell on one company in particular, which is providing one of these services, and that's SpaceX. And they, it's founded by Elon Musk, one of the co-founders of PayPal, and they've pushed really quickly to build up a very impressive capability. So a lot of it is just investment from private funding, but also they've been given grants by NASA to develop their capability as well. So at the moment, they're resupplying the space station as well with a spacecraft called Dragon. So the next one should launch on December the 16th, I think, so very soon. And when Dragon returns to the Earth, it returns and splashes down, and they can retrieve material as well. So it doesn't just go up, it brings things down as well. The other resupply missions burn up in the atmosphere on the way back. So this looks like it's not going to work, but I think it's going to. Where's the pointer there? Right, so this is one of the SpaceX rockets. So this is a Falcon 9 test rocket being launched in Houston, in Texas, and you can see it taking off, and everything's going well. Now, it's a really impressive feat that they've managed to achieve with this rocket. You'll notice those legs sticking out; they're still there, and the fact is they're landing legs. So this rocket doesn't just go up; it also comes down as well. So this was a test flight just to try out landing with these legs. Let's skip forward a bit. And again. So you can see, as well as going up, it can come down. And the reason they're working on this is to make the Falcon 9 reusable. And so all the Falcon 9 rockets, the ones that aren't carrying payload which is too heavy, they've been experimenting with these landing legs. So the space shuttle is, as you probably appreciate, was reusable, or a large part of it. Was, some frightened cattle there. But it's fantastic what they've achieved with this. So these are the legs on a Falcon 9 prior to launch, and if I go back, this is the one let's see. Yeah, so this is a view from above. It'd help if I played it, wouldn't it? So they had a quadcopter next to it. Hopefully not too. So when you think about how difficult it is to balance things like that, it's a really impressive feat. So they've actually tested this on real missions. So they had a launch in July this year where they tried out these legs, and they sent out an aircraft to actually film it coming back down. But because it's not fully tested yet, instead of returning it to Earth, they wanted to land it on the sea first. So you can see the rocket coming back down. So it's launched. The next bit of the rocket is left, and then this bottom bit is coming back to Earth. It fires the rocket, and then just before touching down on the sea, the camera misses it, unfortunately. But it did work brilliantly. So very soon, I'm not sure if it's the next flight, but in the next few flights, they're hoping to demonstrate a rocket that's going to return possibly first to a floating rig and then back to dry land in Florida after launching, and then they can reuse that bit of rocket again. So this will lower the cost of space flight with the Falcon 9 rocket significantly. So the Dragon spacecraft at the moment, it's just a resupply spacecraft for the International Space Station, but SpaceX has just been given a grant to develop this to carry people as well, and the capsule as well will land on dry land. And the Boeing company as well has been given a grant to develop and demonstrate their own manned spacecraft as well. Okay, so this is called Orion. So the missions up to now I've shown you to go back and forth to International Space Station, so not too far into space, just a couple of hundred of miles up above us. But Orion is designed to go back into deep space like the Apollo spacecraft, so to the Moon, asteroids, Mars maybe, in the next few decades. So last week they tested a big part of this, which is the main capsule, and the rear bit is being provided by the European Space Agency, including some bits from the UK as well. So this back bit is from the ATV, or based on that, which is the bit that goes back and forth to the International Space Station from Europe. So you see the European version of this figure has got the capsule in the background with the service module in the foreground. So last Friday, I think, this capsule was tested for the first time, no people on it, but they wanted to show that it could come back to Earth at really high speed. So to do that, they had to send it really far into space, so a few thousand kilometers up, and then for it to re-enter. So it was launched on a Delta Heavy rocket, and then a few hours later, it splashed down in the Pacific, very reminiscent of the Apollo splashdowns after the moon landings. And this spacecraft is still being developed, so this will be the full version called SLS, and it's very reminiscent of Saturn V, but also it's using space shuttle technology as well. So it's an exciting time, and the next decades, very quickly, the next mission will go past the moon in 2017. Don't know what happened there, sorry. And then the next mission after that may not be to the moon, it might be to an asteroid, and that's so you'll need a couple of launches to send up different bits of the spacecraft, and then it'll leave Earth, go to an asteroid, and then a few months later return to Earth. So it's a more manageable target than going to Mars. If you land on Mars, it's very difficult to get back up again. With asteroids, as we've seen at Rosetta, at a comet, a very similar type of body, you can take off again very easily by just standing up too quickly. So this is what Orion should look like, going off into deep space. And so At the moment, there are no firm plans for missions to asteroids and Mars and things, but the asteroids are probably going to be the next target for Orion and the SLS system. But as we know, we don't know political events either, and China are advancing really quickly, and we'll see what happens with their space missions as well. So finally, a bit of going really beyond the solar system, so interstellar travel, but it's not that unbelievable because we actually have spacecraft that are traveling between the stars now. So there are 4 spacecraft, Pioneer 10, 11, and Voyager 1 and 2 that are going fast enough that they're actually leaving the solar system. But it's going to take tens of thousands of years for them to get to the next stars. They have the Voyager spacecraft have got records on them, recording what things are like on Earth, and the Pioneer spacecraft have got little plaques showing where the spacecraft came from. But in astronomy, we're finding planets now which are almost as small as the Earth and around other stars. So 20 years ago, this really was unbelievable, but as of this evening, I checked, and there are 15,023 confirmed planets known around other stars. So this is how far away they are from their star. So that's the distance of the Earth, and that's how massive they are. So that's the size of Jupiter up there. So as our observations are getting better and better, we're finding smaller and smaller planets, and we haven't quite found a definite planet that's about the same size as the Earth at the equivalent distance from the Sun or from the star as the Earth is. So 10 years from now, there's a mission called Plato, which has just been selected earlier this year by the European Space Agency, and it's just going to stare at thousands of stars for months and years, looking for the signs of planets crossing the disks of distant stars. And so we can find planets using the telescopes on Plato. So as one of the leading scientists on Plato said last week, we're going to devalue the exoplanet. We're going to find so many with this mission. They're going to be 10 a penny, and it's going to be amazing. With thousands upon thousands of exoplanets to study, we know where to point our telescopes to learn more and more about these distant worlds. But the frustrating thing is we can't get to them within our lifetimes. All we've got are what we can learn from looking at them from a huge distance. So how do we travel to these other star systems? Well, at the moment we can't. It's way beyond our technology at the moment, but there was a study by the British Interplanetary Society in the 1970s for a mission called Daedalus, where they'd basically fire miniature bombs behind a spacecraft. And there are other studies with light sail, so if you fire a laser off towards your target to push away a sail away from the Earth and away from the Sun, you might be able to reach another star in a few decades' time. And although it's very early days, so solar sails have been flown already in space. This is a Japanese one called Icarus, which have successfully demonstrated you can actually use, if you make a sail big enough and the spacecraft's light enough, you can actually push a spacecraft away from the Sun just using sunlight. So I'm afraid it's going to be many centuries, I think, before we see sites like this. For now, I think what we are learning in our own solar system is really spectacular in itself. These are bodies that we can visit with unmanned spacecraft already, and in a few decades we can, I'm sure, send astronauts first to Mars and then further afield. And just to put things in perspective, in July of last year, the Cassini spacecraft, when it was orbiting Saturn, it was planned to take pictures of Saturn from the far side, and it was known that Earth was going to be in the picture at the same time. So NASA pushed for everyone on Earth to wave at Saturn at that time. So it was like an enormous planet-wide selfie. So they wanted this to be an international affair, and they asked the Cassini team members for translations, so I pushed for a Welsh one. So that's an official NASA Welsh picture to push for people to wave at Saturn. And this is the beautiful image that was sent back. So 900 million miles away, that's the dark side of Saturn with the rings, and the sun is hidden behind Saturn there. And that's where we live, that little blue dot. So everywhere you've been, all the people you know, all the photos you've taken, all the films you've watched, everything's happened on that tiny dot there. And if we zoom in, we can see the moon next to it, and we think of the moon as being really far away. It takes a few days for us to get there, but from the distance of Saturn, it's nothing. So it puts things into perspective, but we've taken a few short steps only to our next planetary body next to us in space, but in a few decades, I'm sure we'll be spreading further afield. Okay, with that point, I'll leave things. Thanks very much.